This video is for familiarization only and is designed to assist in pre-emergency planning for incidents involving our nation's railroads. The information presented in this video can assist your agency in developing safe and effective protocols and incident response procedures. This video and the information contained herein is not intended to take the place of actual training, replace basic safety rules, departmental guidelines, or established regional response protocols. Near Chatsworth, California, a head-on collision of a Metrolink commuter train and a Union Pacific freight train occurred at approximately 40 miles per hour. 25 people died in the collision, including a Metrolink engineer. The freight train had two locomotives. The lead locomotive contained the conductor and engineer who were trapped inside while it was engulfed in flames. They were banging on the windshield to get out. They were rescued by the fire department. The second locomotive contained the brakeman, who was injured but escaped. Think about how you would respond to a large-scale emergency situation. Do you have a prepared plan to handle a railroad incident? What actions would you take when responding to an incident? It's important that all responders understand the basics of railroad operations: equipment, safety, hazards, locating and approaching the scene, and finally, rescue operations. There are an abundance of railroads in each state. In fact, today there are roughly 500 different railroads operating in the United States on thousands of miles of track. Track ownership can be complicated, and it's not always as simple as looking at the markings on a locomotive for the answer. U.S. railroads are not owned by the government but are private industries which own the land and the structures that support its track and track rights. Multiple railroads may share the same track, so it's not as easy to determine who's responsible for the track. Becoming familiar with the railroads operating in your jurisdiction and the types of products they regularly transport will be helpful in developing a local incident response plan. Along with an understanding of the products that are transported through your territory, an understanding of basic railroad operations, policies, and procedures is also helpful in planning an emergency response that requires you to be on railroad property. The Federal Railroad Administration, FRA, is an agency in the United States Department of Transportation, or USDOT, whose primary purpose is to promulgate and enforce rail safety regulations, administer railroad assistance programs, conduct research and development in support of improved railroad safety and national rail transportation policy, and consolidate government support of rail transportation activities nationwide. The FRA website provides a good starting point for research and information. Additionally, the FRA provides information on identifying the railroad company's operating areas and locations of all crossings by milepost on their website. You can also check company websites for information about the railroad operations in your area of responsibility. Another resource is the Current Emergency Response Guidebook, which is written for first responders during the initial phase of a dangerous goods, hazardous materials transportation incident. Most large Class I commercial railroads can supply help in developing an emergency response plan, or ERP, that can be added to a local or regional general emergency response plan. At a minimum, the ERP should address railroad maps, locations of railroad tracks and highway rail grade crossings, rail tunnels and bridges that may impede your access to railroad property, locations of vulnerable facilities such as schools, hospitals, watersheds and water supply points, power facilities, or other infrastructure locations, public activity areas with close access, contact numbers for track owners and the railroad's emergency communications facilities, contact numbers for local and/or regional dispatch centers, and a description of commonly carried tonnage, especially hazardous cargoes, and local industrial customers serviced by the railroad. Railroad tracks can appear in different configurations and display no outward indication of ownership. There may be only one set of tracks where trains may run in either direction. Track may be shared with multiple railroads. There may be multiple parallel tracks, of which each set of tracks may be owned by a different railroad company. So contacting one railroad company to have an active track shut down doesn't necessarily guarantee that other tracks will also be shut down. This is especially a concern where track locations intersect. The scene commander has to ensure the proper railroad dispatch authority and the track owners are notified to ensure railroad traffic is shut down at the scene. Anytime you are within the working area of a set of tracks, you are in the railroad's right-of-way. The right-of-way refers to the railroad track and surrounding area, generally defined as an area that extends outward 25 feet from the center line of each set of tracks, but this may differ slightly for each railroad. The right-of-way owner is normally the entity that dispatches locomotives and manages the track. However, relying on the railroad company name displayed on a locomotive or equipment seen on the track to determine track ownership can be misleading. For example, an Amtrak passenger train may operate over railroad track owned by CSX Railway. Determining ownership of the track area is a critical pre-planning event. Emergency contact numbers for responsible crossing areas and tracks are generally posted on signage at each highway railgrade crossing. The highway railgrade crossing refers to the intersection of any road, street, or highway with railroad tracks. Available crossing information needs to be communicated to the Railroad Dispatch Center because the Emergency Response Center and Railroad Dispatch Center may not be in the same location. Freight trains can be over a mile in length and have multiple locomotives at either end of the train. A locomotive is the proper name for the power unit of a train. A train is a series of connected freight cars, either pushed or pulled by one or more locomotives. A typical train configuration has a lead locomotive to move its cars, but may also have added locomotives providing supplemental power to move heavy freight. Extra locomotives don't normally contain additional crew members or personnel, and may be remotely controlled by the engineer in the lead locomotive. A long train could create additional problems in the event of a crash or derailment. Full access to the scene might be blocked, possibly for the entire length of the train. It may be difficult to maneuver around a crash or derailment to reach the opposite side of the train or incident scene. Remember that it's never safe to walk between cars or locomotives unless there's a walking platform and emergency responders know all train movement has halted. Scene control could be difficult and resources may be strained if the incident is miles long and covers various terrain types or multiple crossings. It may be difficult to determine specific hazards due to the length of the scene. A freight train crew is normally made up of two individuals, an engineer and a conductor. The conductor is in charge of the train, while the engineer controls locomotive movement. There may be additional individuals such as brakemen, inspectors, officials, or railroad employees from other train crews. They will generally ride in the extra locomotives. The conductor will have a copy of the train's consist or shipping documents and can answer your questions concerning the train consist. The consist is a detailed listing of all the cars in the train, including notations of whether a car is empty, if the car is non-hazardous, or if the car contains hazardous materials, and the UN identification code for those cars. The train consist will also contain emergency handling instructions for any hazardous cargo. During an emergency, train crews are qualified to look for arriving emergency responders and to report on the train's condition and should present a copy of the train consist. A majority of trains no longer have a caboose. Those have been replaced with an electric end-of-train device that monitors the train air pressure and sends a continuous status signal to the lead locomotive and also serves as a lighted marker on the last car of a train. All trains have onboard radio systems that allow them to communicate with the dispatcher, other locomotives, and the crew if they're out of the locomotive performing routine work such as inspections or other ground operations. Trains may be managed from a dispatch center using rail signals. However, this isn't always the case. In some instances, they are operated in dark territories with no signal system. Between signal points, trains run largely independent, although they do have speed limit zones and speed restrictions based on the type of cargo being carried or track conditions. Most freight trains don't follow a set timetable and are dispatched when fully assembled. Trains operate on a 24/7 schedule. Maintenance vehicles, inspection vehicles, and rail construction vehicles may also be using track for transit during periods when trains are not. The standing safety rule for all track is expect movement on any track at any time and in any direction. Locomotives can have different exterior configurations based on their designed use. However, they are generally of only two power designs, diesel-electric and electric. Diesel-electric locomotives have a large diesel engine that drives a shaft connected to an AC or DC generator to produce electricity. This electricity powers large AC or DC-driven electric traction motors mounted to each wheel set of a locomotive. Traction motors provide propulsion for the locomotive by turning the wheel sets. Most freight locomotives are of this type. Passenger locomotives may be of this type. Electric locomotives also use an electric traction motor, but power is supplied by an overhead electrical catenary or an electric third rail system. This type of power is normally used in passenger rail since installation and maintenance of high-voltage power lines is costly. In general, the specifics of different locomotive models may vary, but the overall locations of primary components stay the same and all operating controls are required by regulation to be clearly marked. Locomotive interior configurations can make access difficult for rescue personnel due to a split-level design. The cabs are generally fairly crowded and contain a nose entrance area, an electronics bay, and a lavatory in the lower area. On newer locomotives, the upper cab area contains the control stand for the engineer, a small desk area for the conductor, fixed or folding jump seats, heavy exterior doors, and access to the electrical panel which contains the battery knife switch and one of 3 emergency fuel cutoff switches. Access for the underfloor mechanical structure is gained through removable floor panels located in front of the electrical panel. On the right side of the cab is the engineer control stand, which houses the major and ancillary components required to operate the locomotive, such as the throttle, reverser, independent and automatic brakes, horn, bell, and sanding controls. The stand also contains gauges, electronic displays, signal repeaters and lighting, and environmental controls. Control stand layout and configuration could be an obstacle, making ingress and egress more difficult. Most modern locomotives have a conductor's workstation on the left side of the cab which contains an emergency brake and communications equipment. There may also be a third seat located behind the conductor's seat. There are also front and rear access doors, the front windshield, and a sliding glass window on each side of the cab. Some cab considerations include the front and rear access doors that are constructed of heavy steel, and the rear door is especially narrow. The windshield is affixed in a heavy rubber gasket and frame, and both the windshield and side windows are made of penetration-resistant glass, all of which can complicate entry. At the back of the cab, behind the engineer's control station, is the main electrical cabinet and panels containing high-voltage and high-amperage circuits, switches, and breakers. Danger high voltage within placarding is displayed on the panel. The main electrical panel houses the battery bus disconnect knife switch and fuse for the 74-volt DC electrical bus. Always check with the train crew to see if they have disconnected the bus, as some engines equipped with auto start features could restart unexpectedly. Even though the knife switch has been disconnected, there may be some electrical circuits hardwired to the battery circuit that are live. Proceed with caution around all electrical panels and circuitry. The interior emergency fuel cutoff push-button switch is also located on the electrical panel. When working around disabled locomotives, be sure to push the fuel cutoff push-button switch even when the locomotive appears to be shut down. Only shut down locomotives at an incident scene if necessary for safety reasons. A running locomotive is required to maintain air pressure for the train's brakes. On trains with multiple locomotives, you need to press and hold the cutoff switch on each locomotive. Emergency fuel cutoff push-button switches are also located on the locomotive frame, usually near the fuel tank fill pipe. Along with various locomotives, there are a variety of railroad cars that can make up a train and may pose a fire, chemical, electrical, or environmental risk to emergency responders. Some of the more common car types include tank car, boxcar, hopper car, gondola car, and flat car. Think about the following incident and how easily it could have been avoided. In Claude, Texas, while firefighters battled a brush fire near the tracks, a train struck their fire engine that was parked in the railroad's right-of-way. 2 firefighters died and another was seriously injured in the crash. The accident investigation revealed the fire department hadn't notified the railroad that they were on railroad property fighting a fire. Remember, the train always has the right-of-way. The average locomotive weighs about 400,000 pounds or 200 tons. The weight of a fully loaded train can potentially reach 6,000 tons. The sheer mass of a train makes it impossible to halt its movement quickly. If a train is traveling at 55 miles per hour, it may take a mile or more for the train to come to a complete stop. This is equivalent to the length of 18 football fields. Trains have the right-of-way, even over emergency vehicles, police, and pedestrians. They move in either direction and can extend 3 feet or more beyond the steel rail. Today's trains are quieter than ever. To a motorist or pedestrian, the train may appear to be moving slower or be farther away than it appears. Emergency responders should never be in the right-of-way areas of tracks, bridges, tunnels, or fouling any crossing without prior coordination and communication with the responsible railroad dispatch center. Let's review an incident involving a firefighter. In Fayetteville, North Carolina, the driver of a 100-foot ladder tower truck was responding to an automatic fire alarm. Meanwhile, the first unit on the scene found an alarm system malfunction and canceled all responding fire apparatus, including the ladder truck. As the driver of the ladder truck returned to the fire station, he approached a railroad crossing with downed gates as a slow-moving freight train passed. As the last car of the train cleared the crossing, the train stopped just past the intersection. Thinking the crossing was clear, the driver drove the ladder truck around the active crossing gate. The driver crossed the tracks as a passenger train traveling approximately 30 miles per hour and headed in the opposite direction on the adjacent track, struck the left front of his ladder truck. Witness statements indicated that the firefighter's view of the oncoming passenger train was likely obstructed by the stopped freight train. The collision spun the ladder truck around and the firefighter was ejected from the truck, sustaining catastrophic injuries, and was later pronounced dead at the scene. It's vitally important to maintain vigilance on or near railroad tracks and property, especially areas with multiple tracks. And it's never okay to disregard active traffic controls or other safety warning devices. Next, let's look at some potential on-scene hazards, such as fuel, electrical, compressed air, wreckage, chemical, track and rail, tunnel and bridge, and railway yard hazards. This list is not all-inclusive, and hazards can come in many forms. Fuel hazards. Depending on the type of locomotive, the fuel tank may contain up to 6,000 gallons of diesel fuel. Fuel may leak out of tank vents if the locomotive is overturned or if the tank is punctured. Diesel fumes may be present in sufficient quantity to cause combustion because locomotive fuel is preheated prior to being pumped under pressure to the fuel injectors. Even if the locomotive engine isn't currently running, some locomotives are equipped with an automatic start to recharge its batteries. Due to residual fuel in the lines, auto start can occur even if the emergency fuel cutoff switch was depressed. For running engines, it may take up to a minute or more for all the fuel in the lines to burn off before the engine shuts down. Electrical hazards. Most locomotives are highly energized and should be treated like an electrical substation when fighting fires. Locomotives may store in excess of 3,000 volts in capacitors located in the electrical room behind the cab and in the rear section of the locomotive. Voltage may be retained indefinitely after the engine has been shut down. Most electrical components are located right behind the cab in the electrical room. Electrical components can be shaken loose or even ejected from the locomotive in an accident. Large lead-acid batteries are typically located under the cab and accessible from an outside panel. The locomotive batteries are part of the engine starting circuitry and provide additional electrical power for lights and other electronic circuits. Batteries can overheat and off-gas dangerous fumes in a fire. Other rail equipment at the incident scene may be energized and contain backup batteries. For example, the crossing cabinets that power the crossing warning systems. Compressed air hazards. Pressurized air operates the locomotive brake and horn. Pressurized air is sent along the entire length of the train and is also used to operate the individual car brakes. Air hoses are pressurized between 80 and 110 psi between cars and 140 psi between locomotives. A smaller hose does not mean less pressure. Hoses are designed to uncouple automatically when rail cars separate, which could pose a hazard to responders. Pressurized air tanks attached to a high-volume compressor maintain a reserve for the air system and store large volumes of compressed air. Treat the air tank as you would any pressurized tank. Wreckage hazards. The railroads have experienced and knowledgeable roadmasters, managers, and supervisors that can help keep emergency responders safe when responding to an incident. Seek out railroad personnel for assistance when they arrive on scene. Hazards may exist even if no hazardous materials are present. First responders may become trapped or injured by shifting debris. Wreckage may appear stable, but in actuality may be unstable. Exercise caution when working in and around wreckage and debris. Avoid stepping or climbing on debris. Items may shift and there are many sharp edges. Loaded rail cars may weigh up to 286,000 pounds each. Empty rail cars may still contain residual product in sufficient quantities to be hazardous. Always assume the incident may have released cargo or residual product into the surrounding area. Locomotive and rail car wheels and assemblies, which are called trucks, are not permanently fixed to their frames. Trucks may fall off a derailed or overturned car or locomotive. These pieces can weigh as much as 10 tons and can shift or fall suddenly. Steel rail can weigh up to 136 pounds per yard. A typical 40-foot section of rail can weigh over 1,800 pounds. Chemical hazards. There are approximately 400 to 500 gallons of lube oil, 50 gallons of sulfuric acid in the batteries, and up to 6,000 gallons of diesel fuel on a locomotive. The train may be transporting a large amount of chemicals as part of the consist. Determine the contents of the train as quickly as possible by speaking to the conductor or engineer. Visual markings, such as placards on the rail cars, indicate contents and hazard potential. Railroad representatives, either on-site or through dispatch, may confirm changes to the train consist that may have occurred along the route. Reconfirm with additional sources if there is any doubt. Assume that any derailment or wreck is a potential hazard zone until on-scene investigation proves otherwise. Track and rail hazards. Trains may not be the only vehicle on the track. Stay alert for maintenance and inspection vehicles. Expect movement on any track at any time and in any direction. Confirm that traffic is stopped on any adjacent tracks. Remember that adjacent tracks may be owned by a different railroad. Beware of slipping and tripping hazards around the tracks. Do not step on the rail. Always step over it. The rail may be slippery from train wheels grinding and polishing the rail surface. Additionally, the area around the track, especially between the rails, may often have deposits of fuel, oil, or grease, making the area a slipping hazard. Track ballast is the supporting stone around the railroad track and ties. Ballast is of irregular shape with sharp points that helps the stones interlock together. Ballast is often difficult to walk on and may shift or slip under weight. Be careful around track switches. Switches can be activated remotely or manually controlled at the switch. Remotely controlled switches can move without warning and can pose a crush hazard. Switch motors used to pull the track section together generate roughly 1,200 foot-pounds of movement force, so you don't want to get your hand or foot caught if the switch activates. Also, a moving or activated switch may indicate that a train or track vehicle is coming. Some switches have electric or gas heaters to defrost the switch in cold weather. Gas heaters have automatic igniters that can operate without warning. Tunnel and bridge hazards. Never enter a tunnel or cross a bridge without first ensuring rail traffic is shut down. In most cases, there is very little clearance between the rail and walls of a tunnel or the rail and support structure of a bridge. There is generally no place to go in case of oncoming traffic. Along with limited entry and exit points for tunnels and bridges, emergency escape to safe zones are also limited because of restricted clearances. Treat railroad tunnels like any other confined space that requires a self-contained breathing apparatus, as most railroad tunnels don't have adequate ventilation. Railway yard hazards. Railway yards present some different types of personnel hazards. Some of these include multiple tracks, tracks filled with standing cuts of cars or trains being configured for dispatching, which may limit your visibility and field of view. Distractions such as noise and activity in the yard. Remotely controlled locomotives moving without the aid of an onboard engineer. Humping of cars. A hump is a hill or incline down which freight cars can coast to a point where they are diverted to specific tracks so they can be assembled together with other cars as part of an outbound train. Overhanging materials on cars such as banding or cabling that may strike personnel. And sudden movement of cars or locomotives from the coupling procedure or other factors such as a brake's release due to loss of pressurized air or a mechanical failure. When in the area of rail yards and tracks, remember, always ensure the railroad is aware of your presence and required traffic or activity is suspended. Maintain situational awareness of your surroundings at all times. Be vigilant for hazards that could compromise your safety. Never cross under rail cars. Never stand between or near rail cars or standing cuts of cars and keep yourself out of the foul. Never climb over or walk between couplers. If necessary, to cross over a rail car, only climb over cars that have an end platform and the necessary safety devices designed for crossing over. And never attempt to mount a moving car or locomotive. When responding to the scene of an accident, remember that you shouldn't approach the train until you are able to identify what the train is transporting and whether or not there are hazardous materials present that are dangerous to personnel. Ask for documentation. Most common is the train's consist. Remember, railroad officials arriving on scene may not have the most up-to-date information about the train's contents. When communicating locations with the railroad, you can use any of the following reference points: railroad milepost markers, railroad signal numbers, and USDOT highway rail grade crossing numbers. While a railroad emergency can happen anywhere, a highway rail grade crossing provides a particularly vulnerable point because some crossings are not equipped with lights or gates. Remember, expect movement on any track at any time and in any direction. In most instances, train crews are required to sound the locomotive horn when approaching a highway rail grade crossing. However, there are circumstances such as mandatory quiet zones where use of the train horn is restricted. It's important to be familiar with the location and number of the crossings in your area. At every crossing, there will be an emergency notification sign containing the railroad emergency contact information. Calling the number will put you directly in contact with the railroad responsible for that crossing. The USDOT number and milepost number can be used to identify the location of the crossing or area to the railroad. The FRA or your local railroad representative can assist in correlating the railroad crossing points in your area to your emergency response maps Additionally, the FRA has developed a rail crossing locator mobile application that provides the user with access to the Highway Rail Grade Crossing database and map features from a mobile device. The tool allows users to locate crossings by U.S. DOT crossing ID, address or geolocation, access inventory records submitted by states and railroads, and view accident history. Incident commanders should use information from all departments on scene in order to escalate necessary responses, including outside agencies, to take defensive actions to rescue railroad crews or others in peril and prevent release of hazardous products. Commanders should control area access until operations have concluded and be prepared to inform the media of situations that affect the well-being of the general public. The following are some initial tasks that will aid in the protection of all on-scene personnel. Ensure railroad operations have ceased. Stay at least 25 feet away from the track until you have received confirmation that the rail traffic has been halted. If the train crew is able to assist, they are the best source of information regarding train operational schedules and communicating with the dispatch centers. Remember, the train crew may be under extreme stress and may often feel responsible for an incident, even though they have done all in their power to prevent an accident or incident. If the train crew isn't available, check with other first responders such as law enforcement to determine if they have already established contact with the crew or railroad. If you're first on the scene and no crew or other emergency services personnel are present, call the railroad and report the incident. If you're not sure about the number to call, look for the emergency number posted at the nearest railroad grade crossing. When communicating with the railroad, identify your location and ask the railroad to cease all rail operations on the track and adjacent tracks. Provide the following: your name and number, incident commander's name and title, if known, the type of incident, and the location of the incident. Other information you'll need from them includes confirmation of track shutdown, the railroad emergency contact information, such as name, phone number, and ETA, and any available information on the train crew and the contents of the train that they may be transporting. If you can't establish communications or you're not sure that rail operations have ceased, it's best to establish a safe perimeter. To do this, flaggers should be sent out along the right-of-way, a distance of 2 miles in both directions from the scene of the incident, equipped with radios and flagging devices. Flagging is a universal railroad signal used to inform a train engineer that they are required to stop. To correctly flag a train, face the approaching train and wave a red or other brightly colored object, flare, or flashlight back and forth horizontally, parallel to the ground. Due to the time it can take a train to stop, flaggers should be stationed 2 miles from the scene in both directions. Don't stand on the track or between the tracks, but stand to the side of the track and far enough away not to be hit by the moving train if it reaches your position. A flagged train should stop prior to reaching the site of the incident. Survey the scene for safety hazards and maintain minimum personnel on the incident scene. Stage additional EMS units in a safe area away from the incident scene until needed. Remind all on-scene personnel to beware of the hazards that may be present at the scene. Be aware of possible hazmat in the train consist. Rail cars containing hazmat may be hidden below other cars in a derailment or conflagration. If the locomotives need to be shut down, utilize the emergency fuel shut-off switches to stop the engine. Remember that once the locomotive is shut down, although it can no longer move via electrical power, the air brakes can release over time, and the locomotive can shift or roll if on a grade. Locomotive and rail car wheels can also be chocked, chained, or blocked to prevent movement. If practical, set manual handbrakes on the cars and locomotives if necessary. First responders should only apply locomotive or rail car handbrakes if the crew is unavailable. Remember, when operating the handbrake, never step on the coupler. Each rail car and locomotive has a mechanical handbrake which is independent of the air brake system. The handbrake is usually located near the end of a locomotive or rail car. Handbrakes are an auxiliary appliance to mechanically apply brakes to the wheels. The two types of manual handbrakes are rotating and pump, or lever. The rotating system uses a hand wheel. Rotating the wheel clockwise sets the brake. Use your leg muscles to lift up on the wheel until it is firmly set. Grip the wheel with your fingers only. Lever-style handbrakes are pumped up and down until the brake shoes are firmly against the wheels. Use your legs to lift the pump handle up and down until you can no longer easily lift the handle to engage. When necessary, the brakes are released by lifting up on the release lever located beside the hand wheel or the lever handle and turning the hand wheel counterclockwise or by operating the lever handle until the brakes release. Make sure there is an actual need to release the brakes since the locomotive or rail car may start to move. Before the manual brakes are released, always be sure to have a secondary stop such as a chalk, chain, or block ready to prevent any unwanted movement of the locomotive or rail car. Fighting fires. The intent of this familiarization on fighting fires isn't to teach you core skills or to replace any standard operating procedures or department protocols. However, there are some things to consider when fighting locomotive or rail car fires that differ greatly from normal structural fires. When fighting locomotive fires, initially treat all fires as electrical fires, regardless of the source. Water introduced into the scene can create electrical hazards that were not originally present. Remember that locomotives are typically powered by large AC/DC motors and have multiple high-amperage batteries on board. Use standard operating procedures that relate to fighting electrical fires in high-voltage locations. If there is no imminent hazard to life or risk of the fire spreading, let the fire burn out. Diesel fires can be an additional threat and will likely need to be knocked down with dry chemicals and possibly foam. Remember to keep in mind where runoff water may drain, such as ponds, rivers, and sewers. The cause of most locomotive fires can include failed fuel and oil system components. A failed or locked motor, alternator, or turbocharger, overheated brakes, electrical system breach, and more commonly, any rotating equipment that has failed and is generating heat. In the event of any emergency involving a train, crews are instructed to seek out emergency responders on the scene and assist in managing the incident. Train crews are a critical source of information about the locomotive, the train contents, any hazardous materials present, and the general composition and condition of the train. Be aware that train crews may be injured or traumatized in a derailment or wreck. They may become trapped in the locomotive cab and require extrication, or they may have jumped from the train and are injured trackside somewhere along the length of the train. Ascertaining the whereabouts and the medical condition of the train crew is an important first step upon arriving at the scene of an emergency situation. In situations where there is equipment derailments, freight may have shifted or become dislodged, rail cars may be stacked or lay across the tracks. Locomotives may be unstable or even overturned, making access to a trapped or injured crew a challenge. This is when a basic knowledge of locomotive design and construction can provide the foundation for the safe extrication and rescue of personnel if it becomes necessary. Conducting a search. When searching the train for the crew, their most likely location is in the lead locomotive cab on the floor or the bottom of an overturned locomotive. Locomotives differ from trucks, autos, and other forms of transportation as there are no installed seat belts to restrain the crew. Because of that, crews may lie down on the floor of the locomotive to brace for impact. If a crew member is missing, check the lavatory and the areas in the nose of the locomotive cab. If you are unable to locate the crew, check along the track as they may have jumped before the crash. Trains with multiple locomotives may contain other personnel in the other locomotive cabs. Entry and egress. There are several possible entry and egress points on the locomotive. Let's discuss the various points and some of their characteristics before we discuss some of the pros and cons for these locations and the standard tools available for use. Keep in mind, the entry and egress decisions should be based on several factors such as the presence of obstructions, difficulty of entry while wearing cumbersome items such as a breathing apparatus, accessible extrication portals that can accommodate a backboard or stretcher, and the lift height with available manpower, just to name a few. General entry and egress to the cab is normally through the door in the lower forward area of the cab called the short nose. On newer locomotives, the current configuration is an outward swinging steel door at the nose of the locomotive that leads to a small inner compartment. This compartment also has an outward swinging door that provides access to the lower cab area, which contains the crew lavatory, the locomotive electronics bay, and steps leading up to the main locomotive cab area. The main cab contains the engineer and conductor workstations and locomotive operating controls. Older locomotives may not have a door in the nose or even a crew lavatory. The outer door is armored steel and very heavy. There may be a small window in the door. The vestibule inner door is usually not armored and has only a spring latch and handle. The engineer's side of the locomotive has an outward swinging steel door located on the rear of the cab directly behind the engineer's seat and control stand. The door has a handle and spring-loaded latch and typically has an outer hasp that allows the door to be padlocked from the outside for security when the locomotive isn't operating. The door has a thick rubber weather seal around the inner mating area and a small viewing window mounted in the upper half. To the right of the engineer's control stand and seat is the engineer's multi-pane sliding glass window. The conductor's side of the locomotive also has a multi-pane sliding glass window identical to the one on the engineer's side of the cab. Typically, there isn't a rear door on the conductor's side of the cab. Keep in mind that the front windshield is an alternative entry and egress point to the locomotive cab if the side windows are obstructed or inaccessible. For side window and windshield entry and egress. These side windows are probably the best point of entry. These windows are made of multiple-layer laminated glass and are impact-resistant. They have a simple mechanical lock installed on the inside. They are a lift-out style with a simple 2-channel sliding track. Pros: provides for quick entry and exit, even for tilted or overturned locomotives. Provides a flat horizontal work surface for locomotives on their sides. The opening can be large enough to accommodate a backboard. The glass can be broken or cut and removed to widen the entryway. The entire window assembly can be completely removed in a single piece from the exterior of the locomotive if time permits. Cons: debris and glass may fall inward on personnel. The average locomotive is about 15 feet in height, and the windows are near the top. Rigging may be needed to help extricate trapped individuals if there isn't enough available manpower for a hand lift. Side windows or front windshields can be broken and removed using a Halligan tool or axe. Pros: provides quick entry and is non-sparking. Requires no power source. Cons: can knock glass and debris in on the engineer or conductor. Created access hole may have sharp edges. Side windows or front windshields can be broken and removed using a reciprocating saw or chisel. Pros: a reciprocating saw generally cuts through glass quickly. Cuts down on the amount of debris cast inward. Cons: saw blades can dull quickly and may require numerous blade changes. Both the saw and chisel require power for operation. Roof entry and egress. Pros: the roof generally provides a stable platform on upright locomotives. A large opening can be made for extrication of personnel. Cons: may require medium to high power tools. Different locomotive models will have different challenges, such as electrical wiring for antennas and electronics, internal framing and support structures, insulation, and layered vibration dampening material. The Halligan tool and chisel are ineffective. For roof entry on newer locomotives, when using a K12 ring saw, cut a square opening. Don't cut an X pattern, as it takes just as long to cut and produces an additional hazard from the sharp edges of the X sections that are peeled back. Pros: the saw quickly cuts through a wide range of materials. It's easy to handle and flexible to use. Cons: the saw is heavy, weighing approximately 24 pounds, produces a lot of heat, and a large volume of sparks. A plasma cutter will present the same dangers as the K12, as it's a high heat source and has the potential to spark an ignition. Pros: works very fast. Doesn't require specialized skills to operate. Cons: produces excessive smoke, limiting visibility. The sparks and heat produced may ignite fuel, vapors, and other combustible materials like insulation. Additional considerations when choosing between the roof and an alternate entry location can include Frame supports and lateral cross members are different in older locomotives versus newer ones. Older locomotives are common in short line or regional railroads. Locations of major installed electrical components in cab wiring differ in locomotive types. Materials and thicknesses differ in cab designs, and newer locomotives will have thicker metals and harder alloys. Hydraulic tools can be used to remove steel doors in the event of obstructions at the windows or roof, or if the door is the most suitable entry and egress point. Pros: cleanly removes the door. If the doors are crushed in, the egress point can be expanded using a spreader. Can be used if the door is damaged. And door hinges can be removed quickly using a reciprocating saw if required. Cons: doors are very heavy. Door openings are typically narrow. Can be a slow process. And may require rigging to remove the door. And handling tools in confined areas can be awkward and difficult. Scene release. As the emergency situation becomes more controlled and the initial hazards resolved, more of the cleanup and normalization of operations can be turned over to the responsible state and federal agencies and to the responsible railroad industry personnel on scene. The presence of emergency responders should be scaled down as soon as possible so they may recover equipment, resources, and manpower and return to their local areas of oversight to continue emergency services. The decision to fully or partially release the scene will be made by the incident commander. In certain circumstances, allowing rail traffic to partially operate at restricted speeds and conditions may assist the railroad in resuming normal operations. Be sure to clear this with the responsible railroad personnel and all other law enforcement and emergency service personnel on the scene prior to moving or resuming any train traffic. The scene should only be released to authorized railroad personnel. It's prudent to ask for identification from any individual that claims to represent the railroad. Be sure to record their name, title, and contact information. Inform railroad personnel when emergency response services have concluded and all responders are clear of railroad property. Resources. It's wise to identify the relevant railroads operating in your response area and keep their emergency contact information readily available and up to date. The National Emergency Number Association, known as NENA, published the NENA Railroad and Public Safety Answering Points Interaction Operations Information document that provides information and guidance for operational interaction between public safety answering points, railroad call centers, and railroad sworn personnel in the field. The Federal Railroad Administration provides detailed documents and online resources to guide you in responding to an emergency involving a railroad. The website also contains facts and documents related to the general operation of railroads, regulations, and rules governing the tracks. Operation Lifesaver is another online source for rail safety education. Operation Lifesaver's mission is to end collisions, deaths, and injuries at highway rail grade crossings and on railroad property through a nationwide network of volunteers who work to educate people about rail safety. They provide training videos, online education resources, as well as public awareness materials.
Thank you. We're all on the same team.